Hi, this is Bill Jacobs. I'm a product manager in Microsoft Advanced Analytics Product Management, and I'd like to tell you today about Microsoft R. But before we talk about Microsoft R, let's talk about advanced analytics and the big why. The big why is captured fairly well in this study that we sponsored with IDC, assessing what would the likely impact be in differential business benefit between those companies that are leaders in using their data assets and those that are not. What IDC measured over about 2,000 businesses was an anticipated benefit of about $1.6 trillion total dollars over a period of time from using big data and the analytics that they could apply to that big data to build better products, to build a more appropriate experience for their customers, to make their operations more efficient, and to enable their employees to get more done. That's a huge number. And so you should be asking, how can I capture that for my organization, my agency, and my business? Well, it's not an easy task. Historically, data scientists, the purveyors of predictive analytics, have oftentimes been independent organizations and essentially solo operations within an organization. That's rapidly changing. Those organizations that use their data assets very well are very quickly realizing that it is the combination of essentially 5 profiles that must work together well to create the types of applications that allow the business to get their hunk of the $1.6 trillion data dividend. And the 5 audiences are the ones you would expect. The data scientists for certain, but they must work in closer concert than ever before with the data engineering team, the platform engineers that build up the data platform, the application developers who now will deploy in an automated fashion the results of data science, and certainly the business users who know where to apply data science to achieve a better result. This is not an easy task. There are 5 major burdens that face anyone attempting to embrace big data analytics in their organization. The biggest one is talent scarcity. Most organizations are trying to hire these people, and so some of the hiring processes have gotten, shall we say, exotic. Bonuses and offers to attract exactly the talent that all of your competitors are after. Productivity is not particularly great in the data science world. The integration of data science results with other applications is today an exercise in converting models into languages like Java. It's a slow, tedious, error-prone process. Infrastructure used to build data lakes is probably more complex now than it's ever been, and it needs to become simplified. The innovation rate as a result of these other barriers is fairly low. The time it takes to identify a problem, do the experimentation necessary to find a way to solve the problem, build out a path to deploying, governing, and securing that result, and then delivering it to users is 3 to 6 months on average. And finally, if you're using existing legacy products, you're probably experiencing fairly high license costs for those products. These barriers can be fixed. It's what we're doing with Microsoft R. Microsoft R is a family of R-based products that live both independently and inside of our SQL Server database and other platforms to give our users a multiplicity of methods by which to take data in the organization, apply predictive analytics to develop learning and insight, and deploy that directly as applications usable by the business's customers, the business's suppliers, on which they can take direct action. But let's talk about R first. Why is R important? Well, the first thing is to realize R is important not because it's a language. Certainly it's a language absolutely directly tailored to the needs of predictive analytics professionals, but it is used in a huge and growing community. Those growth rates I'll show you in a minute. We measured the size of that community at about 2.5 million a couple of years ago. It is so diverse and so divergent, it's hard to measure now. The ecosystem that is built up around R delivers to our users somewhere in the range of 7,000 or 8,000 packages of algorithms freely downloadable from industry repositories at 0 cost. And so R is much more than a language. It is a language, an ecosystem, a community, and a vast array of techniques that data scientists can draw from in solving new problems. The result is R has grown at a surprising rate. We watched the jump several years ago in the Institute of Electrical and Electronics Engineers, or IEEE Spectrum Survey, from number 9 to number 6, and we're rather shocked at that leapfrog. The growth continued this past year in the 2016 survey as R's popularity eclipsed that of very commonly used languages like PHP, JavaScript, and C#. leaving R as the number 5 most frequently used language in computer science today. Well, what does Microsoft do for this? The open source languages are great. They typically come with community support. The R language itself is a single machine language, and so there are limitations in R in its applicability in an enterprise context. Microsoft R products seek to solve that. We seek to provide the ability to scale R to enterprise class problems, whether that's lots of data or lots of users. We remain 100% compatible with open source R, and the reason is, if the value of R in its community is in part hinged upon having access to thousands of pre-built packages, compatibility with and maintenance of a product that's based on open source R is critical. Microsoft does exactly that. We extend open source R with a range of scalable functions that are designed to allow our users to go well beyond what open source R can do, particularly in analyzing very large data sets that exceed the capacity of the machines on which they're currently operating. We also allow intrepid R users to build their own custom parallelized applications and deploy those using frameworks that are part of the Microsoft R product. And the results of their work are portable through what we call write once, deploy anywhere portability. And I'll get back to that in a little bit. But we talk about scale. This is an example of the performance improvements available for users of Microsoft R. The blue bar is a depiction of the performance rate and the data size capacity of the open source R generalized linear model. It's a very commonly used logistic regression algorithm. The red bar is the effect that Microsoft is able to bring by creating an equivalent algorithm that is massively parallelized, remote executable, and most importantly, rewritten in C++ to maximize the performance of the algorithm. And as you can see, there's about a 40 to 1 difference in the performance rate and essentially no limit to the scalability of the Scale R version of GLM that we ship with the Microsoft R products. In addition to scale and performance, the question is, can we really scale to very large data sets? This chart depicts it. RxLogit is a logistic regression algorithm. We measured how would it scale on a 100-node cluster as we increase the data size. We stopped at a couple of terabytes of data, and as you can see from this curve, we're scaling essentially linearly as we add more data to the data set. Portability allows us to run the Microsoft R products on a wider array of platforms than anyone else in the industry. And that not only includes R, that includes the scale extensions to R in the lower 3 blue boxes on the slide, the deployment gateways called Deploy R that enable us to connect R to web services calls to deliver APIs to our application developers, and tools that allow Visual Studio to be used as a very fast, powerful IDE for the development of R that then gets deployed into all these platforms. And so with Microsoft R and our deployment capabilities, our users are able to build analytics that then become embedded by application developers. This is an example of a Power BI application that is doing campaign management and predicting what is the best way to contact a household or an individual and what's the time of day and the mechanism whereby we'll get the largest response rate. Typical predictive analytics in a marketing context. It's invisible here to the user, but it's actually using R-based predictive analytics in behind the application to add prediction to the application. One of the other major challenges for big data analytics professionals today is, how do we embrace the cloud? For most organizations, existing applications running on-prem are difficult to lift and shift to the cloud. There are times and places where we absolutely think that's the right thing to do. But Microsoft R adds an incredibly powerful way to look at the cloud. Because we can build in one application, one environment, and deploy in another, it's very practical for users to think, well, if I build the data lake in the cloud first, I can build predictive models in the cloud and then port those, directly deploy them into on-prem assets. This frees the data science teams from waiting until the entire application stack is in the cloud before they can enjoy the benefits of speed, performance, and scale and cost that the cloud offers. And so with Microsoft R, what our users and data science teams are able to achieve is, number one, the peace of mind that comes from utilizing a commercially supported version of R that is efficient, that makes deployment of models easy, that allows you to tackle big problems, large data sets with speed and scalability, and the flexibility to deploy the resulting predictive analytics in a number of additional application environments, all from a single R product. This tackles the 5 major burdens that most organizations feel. By utilizing R as the language, we expose organizations to a much broader talent pool from which they can hire. We improve productivity by allowing work to be done in any of a number of environments and directly deployed into yet more environments. We modernize infrastructures by helping people look at ways to utilize the cloud for modeling if they wish and deploy on-prem, or build the data lake on-prem but run their models in the cloud where the data is flowing. We maximize innovation rates by bringing R and pure open source R to bear on these problems so that the talent and capability of millions of our users can be brought to bear on innovation problems. And we drive down TCO by embracing open source, which is fundamentally a major disruptive force in the analytics marketplace by bringing a broad capability at a very modest price to the R-using community. And so what I'd leave you with is a series of possible actions to learn more about Microsoft R. Have a look at the Microsoft R page on the Microsoft website. There are videos there, a couple listed on this slide. Download a copy of the product if you like. It's available in a number of forms on MSDN. Or you could spin up the Microsoft Data Science Virtual Machine in Azure and run that within your subscription. It has a completely tooled out environment containing tools and R interpreters, scale capabilities, data sets to play with, lessons, all in a single VM that you can do very easily. So there's a lot here. I'll leave you with that. Have a look, learn more about it. Let us know how we can help you. Thank you.